happy day. It's a wonderful day. What is it, July 12th? It's
Sunday.
Sunday, hot outside, you know.
I got up to run at 6:30 this morning, and it was already 80 degrees at 6:30.
It's going to be fun. But, you know, you guys are probably watching this in like October or something, so who knows. Anyway, all right, we're going to talk about the least squares regression model today. And this is going to be possibly a pretty long video, so
Hold on to your horses.
Hold on, let's do it. All right. So, you want to tell me what I'm looking at here?
So what we want to think about, you know, in the last video, we talked about our least squares regression line, but we didn't call it that. We called it just the regression model or the linear regression model. And so we're going to add a little bit to that now, because what's actually happening with this model is the computer is creating squares using the residuals that we talked about in the last video and trying to minimize the sum of those squares if you were to consider squares on top positive, squares on top negative, or something along those lines, okay? Kind of alluded to this in the last video.
When we talked about those residuals, we said if the point is above the predicted line, the residual is positive, and if the point is below, another point is below, its residual is negative. Well, positive and negative, when you combine them, add up to, you know, we said they all added up to 0. So there was really no way to measure those errors. So there was a way, the way to get around that is to take those positive numbers and those negative numbers and square them. When you square a negative number, it becomes positive. So we have all of the errors squared, and it's graphically represented. That regression line pivots on that average X, average Y point so that those squares are as small as possible. We'll talk more about this a little bit later on. But
yeah, that what you're seeing there, that point that he just put, the X bar, Y bar, if I were to add up all the Y's and divide by the number of Y's, I get, you know, the number in the middle-ish. You know, it is.
I eyeballed that, but that would be average X, Y point. And then it pivots. The line pivots and the squares get bigger and smaller. We'll see that later on. Okay, so let's move on. All right, so there's some formulas from our statistics sheet that we're going to talk about. In particular, I know like you guys are familiar with Y. We've talked about Y equals Y hat. I guess actually we talked about this guy, right?
Yeah.
And essentially that's the same as the one on the right, except it's using the X bar, Y bar point. We'll use that one a little bit. And Miss Young did talk about this guy a little bit about finding the R value, but I don't think you're ever going to actually have to find it by hand, but you're going to have to interpret the R value, and knowing that value, that formula does help you make sense of things.
So what happens here is, you know, there's different ways that we can find the model, the regression model. And most of the time, you're going to put the data in either like Excel or your calculator or something like that, and you're going to ask it to find the least squares regression line. But what we could do is we could say, okay, what information do I have? Because I can calculate the slope if I know the standard deviation of X, the standard deviation of Y, and the R value. I would just divide the standard deviations, just like slope is normally done, Y over X. So standard deviation of Y over standard deviation of X times that R value. And that would give me slope, okay? And then we can solve for y-intercept the way your algebra teachers have always taught you to solve for y-intercept, right? Plug in slope, plug in your X, plug in your Y, solve for B, which in this case is actually A. Confusing, I know. We're gonna look at an example of what this looks like. And this is a rare kind of thing that you would do. But I do want you to see it happen one time and understand that all of these formulas are available to you all the time. And they will be on the AP test as well. So grab your formula sheet for this lesson because you're going to need it here in the beginning.
Okay, so let's look on the next one. Um, did I go too far? Oh, hey, there's that lovely
That's
sound.
right.
That's right. Okay, I thought I clicked two slides. I'm sorry, my bad.
So you want to read?
Okay, an ornithologist wants to look at a relationship between the breadth of peregrine falcon eggs and the mass of falcon chicks that hatch from them. The data show a linear pattern, and the summary statistics are in that. So all of that's been done for me and provided. By the way, the peregrine falcon is the fastest animal on the planet. It can dive bomb at over 200 miles an hour. I learned that yesterday.
Why?
I was listening to the radio, and it was on one of the.
That is a weird coincidence.
Yeah, it's just a weird coincidence, but actually, it's the fastest animal on the planet.
Okay, so let's see what's given to us. We're given that in this problem, you've got X, which is the egg breadth, and Y, which is the chick's mass. And so we're given the mean of all the X's, or the mean of all of the egg breadths, and the mean of all the chick's masses, and then standard deviation for both of those. And then we're also given the R value for the data, okay? So we're gonna, at this point, we're gonna be like, we don't know what to do. I don't even have this formula memorized, guys. So what I wanna do is I wanna go to my formula sheet. So Mr. Robbie, will you make one click happen? So this is what I'm gonna see on my formula sheet is like R, B, Y, average Y, and then Y hat. And I have to decide what should I use. So what do you think, Mr. Robbie?
I don't want to do this R value, but I do. I mean, I know that you had a minute ago, there was a formula for finding B that had some S's and R's in it and stuff. Is that, can I make that happen if I animate it again?
It's right here. Look, B is the R value times the standard deviation of Y over the standard deviation of X, or MI over the.
So I know that formula. Yeah, it was the B. Oh, I'm sorry. I got to click back on my draw tool. So B was the R value times the standard deviation of the Y over the standard deviation of the X, right?
What's happening, guys, is he has me and him over the formula that I just circled, I think.
Oh, I do. My apologies. That's why I couldn't see it, because your face was over it again. So, yes. I know how to use Zoom. I really do. Just your big head was in the way again. All right. So we're going to use that formula. I could not see it, but now I can see it. So I have all of that. I have S sub Y, I have S sub X and R. I need to use these numbers right here. Okay, so I can use that to find B. So I'm going to go ahead and do it. You go ahead and.
Yep, okay. So what I'm going to do here is I'm using my handy dandy phone calculator. So I'm going to take S of Y, which is 4.6, and divide it by 2.3. And then I'm going to multiply that times the R value, which is 0.95. And I'm going to get 1.9.
Okay. And I'm sure you may have more decimals than that, but I didn't. Close enough for government work. Now that B right there is the same B in the linear regression model.
Yeah.
So I'm going to take that 1.9 and put it in, and I'm going to use the Y bar equals A plus 1.9 X bar.
So he's flipping formulas right now from what we actually want, because he knows that we're given X bar and Y bar. So we're probably going to be using that one next. Okay. That's why he jumped to that formula.
So now I need to put 33.6 and A.
So we're going to do 33.6.
And then 1.9. And X bar is 41.
Yeah. So we're going to do 1.9 times 41. And that's going to give us 77.9.
And we're going to
We're
take
going to do
that away from
33.6 minus 77.9. See here, 33.6. And we're going to get negative 44.3.
Okay. Now, that's okay. I'm going to use that as my approximation for A. So my equation would then be, now I need to go back to y hat, right?
Yeah, because when it asks me to find the equation of the least squares regression line, that's y hat. Y hat is the least squares regression line, not average x and y. But what we do know, what we talked about a minute ago, is that the average of x and the average of y is on every single least squares regression line. That's why it's okay for us to use this, because we know that point has to be on that line.
Oh, I can't write. I was going to say, what is wrong with, maybe my computer got messed up with the nearest 10th.
Well, actually, we would actually want to put zeros on this one if it asked us for hundredths, because everything I gave you was to the 10th place. So like 4.6 divided by 2.3 was actually 2.
Yeah. So if I said 4.30 would be okay?
Yeah.
And they're not going to give you decimal places to put, right? Cram a 0 in there. Okay.
They're not. All right, so guys, we're going to leave this concept now, because honestly, it's so rare that you would find the linear equation model this way, but I did want you to see it one time, especially because those formulas are on your sheet. And I don't want you to, I don't want there to be any formulas on this formula sheet where you're like, what the heck? We've never looked at that.
And what's kind of cool is now you know where the regression equation comes from. When you throw it into your calculator or a computer and it does it, it's doing all of this for you.
Yeah.
So.
All right, moving on.
All right, so I don't know where to put your face now because there's a lot of text on the screen. So so when we get to the sentence stems, I'm familiar. You want to talk through essential knowledge now?
Yeah. So what we're going to look at here is something we actually looked at in the last video, but we're going to formalize. So we're going to be looking at the coefficients of the least squares regression model, which are slope and y-intercept, B and A. Okay. Want to remember that the y-intercept value is the predicted value of the response variable when the explanatory variable is equal to 0. So when x is 0, what is y? That's your y-intercept, okay? Sometimes your y-intercept does not have a logical interpretation. And we saw that in the last video where our truck with 250,000 miles on it was worth $. So you want to think about after you interpret your y-intercept, you want to think about, is that nonsense? And if it is nonsense, say it's nonsense.
It's like the male earning $1,600 when the woman earns nothing.
Yeah. And then we think about the slope as the amount that the predicted y value changes for every unit increase in x. Traditionally, unit increase in x is 1. We'll look at an example where we might change it to something else because it makes more sense to the reader to word it that way. So I gave you some sentence frames or stems so that you could easily write this in the way it should be written. You'll write your y-intercept when x is 0, whatever that context looks like, the predicted, whatever the context for y is the number, okay? So we're gonna look at that, an example of that. And then similarly with the slope, I'm not gonna read that to you. Let's just jump to an example, Mr. Bobby, so that we can put those.
I like those sentence stems because it gives me a framework of how to respond to questions, but it's better to see them in practice.
Yeah.
Okay. So, hey, this is like, is this the trucks again? Yeah, this is our truck.
Tricks.
Now, we actually talked about this a little bit before, but we're actually going to formalize it a little more here, right?
Yeah.
Tell me about the slope. The slope is negative, I'm sorry, yeah, it's negative 0.1629.
So
Oh,
it's,
we,
the first thing
yeah,
it says is determine the slope. And remember that slope for us is B. I know that's so confusing. So, but my slope value is negative 0.1629. And, excuse me, make sure that if it has a minus sign that you actually do put the negative, because that's going to tell us something, okay? So let's think about this. Slope is change in y over change in x, okay? So we want to think about this as change or delta
we won't do it that way, sorry.
price, no, that's okay, over delta miles, okay? So change in y over change in x in this case is delta price over delta miles, or change in price over change in miles. Our number is negative 0.16. And because we want it in units, we're going to just put it over 1 and answer in context over 1. It'll make sense in this case. So let's go ahead and put a 1 down there. Yep, we got dollars. We got miles. And then now it becomes a pretty easy answer for us because it's really laid out for us. Remember, we're decreasing. So for every 1 mile you drive, the price of the truck decreases by 16 cents.
And we did talk about that. I think we said that. We're just formalizing it now.
Yeah.
So.
Do not put decreases by negative 16 cents. That's nonsense. Like, you got a double negative going there. So just be aware of that. And we'll put it in a sentence frame on the next example. So I'm just kind of talking you through this again of how you find these things. Next one says determine the y-intercept. So our y-intercept is 38,257. Remember, the y-intercept occurs when x is 0. So 38,257 when x is 0 is when miles equals 0. So what does that mean, Mr. Bobby?
That means before you even take it off the lot, or even before they put it on the lot, because most new vehicles have like 0.2 of a mile on them because they've been driven on and off the truck. Yeah. And it's initially produced. That's the value of the truck when the odometer reads 0.
Right. So let's put 1 in the sentence frame, Sam. I think the next one, maybe we set it up for that.
Let's go for it. So here, this is our one we talked about last unit about male and female income. And we have the equation, 1,600, so on, plus 1.27x, and so on. The slope was $1.27, or 1.278, whatever here, okay? So this is the slope. You already beat me to it. So the slope with each additional x, what are the x values? Oh, that's the female income, right?
Yep.
All right, we're just filling in the blank. And that would be dollars, right?
Yeah.
Okay. The predicted y, okay, that would be the male income. And again, that's still dollars. Increases or decreases? Well, that slope is positive, so I would put the word increase. Now, you're not going to actually like have blanks. You're going to have to write the whole stem, but you're always going to use this framework. Okay. And then I'm going to put in the value here, 1.2. I'm going to put 2.8 because it doesn't make sense to have all those decimals when we're talking about money.
Yeah.
Okay.
Looks beautiful. So guys, we're not saying you have to use the frames, the sentence frames. It's just if you're struggling in a problem with how to word the explanation of the slope, this is an easy kind of plug and play with how to write it out.
Yeah. And I mean, Miss Watson, my wife is a grader. The more you ramble, the more likely you are, the more fancy and flowery you try to be, the more likely you are to say one little thing wrong. This is almost the minimal you could get away with. And we tell you that because if you answer in this framework, you're answering the question, you're not putting any extra stuff in there, and you'll get the answer. So,
yeah. And then when we do the y-intercept, we're going to say when X is 0, we don't want to say X though, we want to say female earnings. So when female earnings, and I didn't leave a lot of room for him to write, is 0, or $0 in this case.
I'm just going to put dollars there because I didn't predicted male money. And again, I'm spitting back. You're literally going to regurgitate back the labels.
Yes.
Okay. Don't get creative. You don't have to get creative. You can, but the more creative you go, the better chance of messing up. So when female money is 0, the male income is, what do we say, 16, 12?
Yeah, 53.